Okay, Foundations of Pre-Calc 10. Let's get after it. We're going to talk about special angles in right angle triangles. And this video, you'll be happy, is only 6 slides, way shorter than the last one. And it's an introduction to special angles that are going to creep up again and again and again. So for special angles, we have 2 triangles to consider. They're very special, particular right angle triangles. One is the 45, 45, 90 triangle. So you can see you have 90 degrees, and then you have 45 degrees and 45 degrees. So important to consider, if you oriented this triangle like this, people are more used to seeing it like that. You have what's called an isosceles triangle, right? Where this side is the same as this side. So that's what we're looking at in our triangle, except it's drawn up on its right angle. So what that still means, though, is that this side is the same as this side. So what that does is, let's look at that with respect to a ratio. Because with a ratio, you can make that whatever you want it to look like, right? So give it a value. So let's say, okay, well, what if that was 3 and that was 3? Okay, well, so that means that this missing side is going to be Pythagorean theorem. 3 squared plus 3 squared equals c squared. So 9 plus 9 equals c squared. 18 equals c squared. Square root of 18 equals c. Now, you might look at that and go, well, that's not very helpful. And it is and it isn't, because it's just that that is the ratio all the time. Okay, it means that you have, it doesn't matter which angle you pick. If you picked this angle, it means you have sine of theta is equal to 3 over root 18. It means you have cosine of theta is equal to 3 over root 18. And it means you have tan of theta is equal to 3 over 3, right? And the thing is you'll learn in grade 11 how to simplify this, but root 18 is root 9 times 2. And root 9 is just 3. So what you get is you actually get 3 over 3 root 2. And again, this is bonus simplification, but I'm just showing you why. Because those cancel, those cancel. So you end up with a ratio of 1 over root 2, 1 over root 2, and that's just 1. So it shows you that it doesn't matter what value you pick for this. The ratio of these sides in their most simplest form will always be 1, 1, root 2. Those are the special angles for a 45, 45, 90 degree triangle. Sine theta is always equal to 1 over root 2. Cosine theta is 1 over root 2. And tan is 1 over 1. So those are the exact values, the given ratios of a 45, 45, 90 triangle. 1 over root 2, 1 over root 2, 1. So here is what I just did, but if you write it with a hypotenuse of 1. So we just had 1, 1, and then root 2. But if you want a hypotenuse of 1, well, it just means you divide by root 2, you divide by root 2, and you divide by root 2. You do the same thing to each triangle. And you'll notice what you get is, you get the answers we just had. Sine theta, cos theta, right? Because if you wrote them as opposite over hypotenuse, it's just over 1, which is redundant. Now, this comes in handy because if you have a hypotenuse of 1, we can create what's called a unit circle. You're going to see this in grade 12. So just be aware that all of this comes back again, okay? But the ratios are still the same. If you multiplied everything by root 2, we get back to that 1, 1, root 2 ratio. So, and if you multiplied everything by 2, right, you'd have a 2, 2, 2 times root 2 ratio. Right? You can make the ratio whatever you want, but when you simplify it down, it's going to be 1, 1, root 2, and then with a hypotenuse of 1, it just looks exactly like that. It's the answers for sine are given, the answers for cosine are given. So it's just a bonus way of looking at it. Now, what about a 30, 60, 90 triangle? So where does this come from? This comes from the fact that we can draw what's called an equilateral triangle. All sides the same, all angles the same. And let's give these things some values. So let's say, okay, 2, 2, 2. Well, if we drop a perpendicular down the middle, we've created the 90 degrees. Okay, so now what we can do is we can partition this into a 90-degree triangle here in green. Whoa. Try and make this as clear as we can. So in green here, we have a 90-degree triangle. Now, if we partition it, it means this angle now becomes 30 degrees. So we have what's called a 30, 60, 90 triangle. Now, if the whole white section was 2, it means that this is now 1. So we're now looking at half of that equilateral triangle, okay, where we have 2, 1, and then a right angle. So if you use Pythagorean theorem, you're going to have 1 squared plus I'll just use x for now. X squared equals 2 squared. So 1 plus x squared equals 4. X squared equals 3. X equals the square root of 3. So it means that the height of that triangle is the square root of 3. So from here, we get our 30, 60, 90 ratios. Okay, so if we're going to use the 60 degrees, okay, opposite over hypotenuse. So sine of 60 degrees is root 3 over 2. Cosine of 60 degrees is 1 over 2. And tangent of 60 degrees is equal to root 3 over 1, so root 3. If we're going to use the 30-degree angle, do it in green, then now our opposite becomes the 1. So sine of 30 is equal to 1 over 2. Cos of 30 is equal to root 3 over 2. And tan of 30 is now 1 over root 3. So if you remember from our previous video, sine of 60 is equal to cosine of 30. Cos of 60 is equal to sine of 30, right? So those relationships come back. But that's a 30, 60, 90 triangle. These are your ratios. They involve root 3s and 2s. I'll go to the next slide because it's clean. But you can see it's always handy to write your triangle down if you're trying to remember. Just go, okay, here's my triangle. Well, a side across from a bigger angle has to be bigger, and root 3 is bigger than 1. So just root 3, 1, 2, bam. And now it's staring me in the face. I have my answers. But the thing here is I'm going to ask you the same question. What happens if you write it with a hypotenuse of 1? So we had root 3 for the height, we had a 2, and we had a 1. Well, if you want to write it with a hypotenuse of 1, you have to divide everything by 2. And what you get is you get this special angle triangle that has a side here of root 3 over 2, 1 over 2, and 1. And if your angle was down here, your answers are given to you. That's your sine, that's your cosine, right? Because your hypotenuse is 1. And then your tangent is just the division of the 2. So again, that will come in handy. There's a lot happening with special angles as you move forward. But right now, I would say the most important thing to remember is that a 45, 45, 90 is 1, 1, root 2 on its sides, A, B, C. And then a 30, 60, 90 is going to be 1, root 3, and 2 along its sides. So you'll know that your ratios are going to be 1 over 2, root 3 over 2. Okay, so get comfortable with your sine, cosine, in particular, ratios of special angles. There's just a little bit of practice in this workbook because it's a really brief introduction. Okay, good job. We got one video to go, and guess what? Word problems.